Bum, ba, 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 ba. I think this is going to be brighter and and shinier. Hey everybody. Hey, what's going on? Hope everybody's doing good today. Just heard there was a launch scrub from the SBIRS rocket. The news is that it was associated with a quote booster liquid oxygen system. So that's a scrub for that Atlas V launch for tonight. At least according to the latest tweet from Sky Schwartz on Twitter at astro_sky, SKYE. That person says that the launch is planned for Friday, January 19th. Forecast shows a 90% chance of favorable weather for launch. The launch is set for 7:48 p.m. Eastern Time. And 7:48 p.m. Eastern Time, I think, is 5 hours behind UT. So that's you gotta add 5 to that. So yeah, like 148, 1248 UT. I'm gonna get my all my little things going here. Let's see how the video looks. Hey, that looks a lot brighter. So I hope that's better. Let me get the chat going here. Dun, 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 dun. I didn't have this on my agenda, but I'm going to bring it up right now because I just thought of it, and that is I'm wondering if anybody watching or listening later has ever heard of this radio show called Music from the Hearts of Space. Let's see, I have to reload this, I think, in order to see it. Has anybody ever heard of Music from the Hearts of Space? As the name implies, it's a space music show, and it has been going on for quite a long time, since I think they started locally, like in San Francisco, in like the 1980s, early 80s, and then they, I guess the term is syndicated, and went nationwide, where mostly like public radio stations would pick them up, and it's an hour-long space music / ambient / really cool kind of music. Space music, right? But anyway, check them out. That is Music from the Hearts of Space. It's HOS.org. And one of the things that I haven't been doing, and shame on me, because why do you want to look at this? Okay, right? No, I'm gonna share my screen around. So let me get that started, and we can actually look at the Hearts of Space website here. I'll pop it up here. HOS.org. So I mean, maybe it's kind of cool for you folks to. Oh, maybe it isn't HOS.org. Maybe it's HOS.com. If I can type. HOS.com. Yes, HOS.com. So let me come back onto this screen, and then I'm going to share my screen. Sex in the house. Thanks for stopping by again, man. I really appreciate your support. and coming in like you do. Bob Dog, hey, yeah, it's a shiny, shiny cosmic, man. Um, I've got this light over here. It's over in the corner. It's actually a shop light. It's actually a shop light. Okay, I'm gonna share my screen, and we're gonna go over here. So this is the Music from the Hearts of Space website, and every Sunday, they play sort of this week's episode for free. So all day Sunday, you can go to this site, and if you go, what I do at least is I go to programs, and then I go to this week, and this is sort of the song listing for this week, right? Blah, 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 blah. And what I do at least is I just hit the play button right there, and it plays. And I do back when I was a kid, at least, I would hear songs on the radio, and I would get my tape recorder out with a microphone, and I would record the songs that I like. Well, that practice hasn't changed. It's just become completely digital now. So what I do is as the weekly show is playing, I will also record it, and that's probably a violation of something. But look, I'm using it for my own personal use. I don't. I mean, there isn't anybody else around, that really wants to listen to that kind of music. So yeah, and this is the kind of music that I compose, is space music, and it's very ambient. There's some drone. There's some interesting beats. Yeah, just if you've never listened to this kind of music, you probably can't really imagine what it's like. But yeah, I recommend that you take a listen. It's as an astronomer, okay, I think that this music is just, I mean, it puts me right in the zone, right? I mean, just right in the zone. What is FTW? OMCXXX, you say shop lights, FTW, and I'm just an old guy. I don't know any of this newfangled language. So let me know. Let me know what that means. All right, so OMCXXX has already been asking some questions. So let's see. Let me. I guess I'll reluctantly on the chopping block here. I'm glad to see that that's nice and bright, and yeah, nice shiny face too. So it's you're seeing a very, very rare event. So I'm actually it's actually funny that I'm recording this because this I was digging through some things. I was digging through some things, and I found a what are those things called? It's the razor that has the three circular things on it thing. I found that, and unfortunately, I'm not really able to grow a beard because it's so curly that the hair starts to curl, and it just tickles. It's maddening. It's absolutely maddening. So usually I just cut it cut it short, and that's it. But I found this little thing, and so it's like, okay, but that's a very, very, what you're witnessing is a very, very rare event. All right, shock lights for the win. Yes, yeah, I think that's yeah, I think that's better. I'm sort of looking over at the YouTube live feed over here, and I'm gonna put on my headphones just to listen to the audio. Yeah, yeah, that's okay. That's all right. It's echoey, but I'm in an echoey room. I think as the show evolves, I will definitely try to get the some sound suppression of sorts, just to get rid of the echoey, reverby thing. All right, so OMCXXX asks, does a poor explanation for an observation require a different observation or continued and expanded upon explanation of the original observation? Does a poor explanation for an observation require a different observation? Require a different observation or continued? It. I guess I would answer that by saying that you sort of take what you can get. Usually, when you're working on a project, you usually come up with a plan of some sort, and spend a considerable amount of time and effort trying to make a good plan. Now tonight I've changed my drink of choice. This is hydrogen hydroxide tonight. So you got to change it up from time to time. So dihydrogen oxide is okay, but there's probably nothing like a good glass of hydrogen hydroxide. So I'm totally into that. Cheers. So if you have a plan, and following the scientific method, you've come up with some ideas, and you've also come up with some theories as to sort of explain what you're seeing. You go and make some observations based on that. Am I? I don't know if I am or not. No, I guess not. Okay. I was looking over on my chat thing, and the little logo that I think is supposed to be right about there is there, but I don't see it on the live one. So I'm still learning all this. So so you come up with a plan to sort of support your guesses in terms of what is going on from what you're observing, and you collect that data. Hopefully, it's good enough data that you can calibrate, and there weren't any errors made in collecting the data itself. And if that all looks good, you run it through the ringers and see what comes out the other end. And sometimes, in fact, often, you'll come up with some kind of a conclusion that is like, well, okay, that really didn't answer the question, or the results of this work has produced more questions. And that's, hey, I live for that kind of stuff. So that is completely awesome. So yeah, it's a circular thing, and yeah. Okay, so that's his first question. Hopefully that was an okay answer for you. If you want to follow up on that, fine with me. Cassini has discovered Titan has liquid lakes that are connected deep underground, like an aquifer system that regularly transfers mass. Do I think that effect helps keep it in orbit, or do I think events like earthquakes, volcanoes, asteroid strikes may tip the exchange of mass and knock the moon out of its current orbit? Um, the orbits of the planets follow a path that is connected to their center of mass. So even if the mass internally moves around, I don't think it's going to change the orbit. There are moons. Titan isn't one of these because it's so large. It's pretty round, right? But there are moons. There are potato shaped and all kinds of things. Saturn's other moons, and Saturn has, geez, like I don't know how many now, like 50 or 60 or something like that. I don't know how many. Easy enough to find out. But potato shaped, and the only way that those orbits are perturbed is if they have some kind of a close-ish encounter with another moon, or their orbits are already kind of weird, and they actually interact with Saturn in some way. So I don't think, and let me think about that a little bit. I do not claim, nor will I ever claim, to have any kind of answers. It's just things that I know or have heard, or come to some kind of a logical, either inductive or deductive conclusion about them. So I'm not exactly sure. Not exactly sure about that, but I would think that the orbits don't change if stuff is sloshing around. I mean, the Earth is a good example of that, right? There's a whole bunch of stuff, salt water, right? That is sloshing around all the time, and as far as I know, our orbit doesn't move. So the center of mass stays the same, more or less, because more or less it's the same stuff all the time. So yeah. Okay, that's your second question. Yeah, I don't know. That's a really good point. I'm not quite sure if it's dihydrogen monoxide or if it's just dihydrogen oxide. It's there are probably books written on that. So it's a very as you probably know, it's probably one of the most incredible molecules in the universe. So yeah. There's a button, ADL, bottom right corner. Yes, that is exactly what I am referring to. I don't see it on my smartphone, so I'm not quite sure why. But yeah, that's the and it's right. Is it like right there? Let's see. I'm gonna watch, see if I'm pointing in the right place. I think I am. Anyway, that's what YouTube calls branding. So there it is, ADL, Astronomy Daily Live. And here it is. This is Astronomy Daily Live, coming at you every single day at 2 hours UTC. So I'm in the United States in southeastern Arizona, in a very, very dark, quiet location. And that's exactly how I like it. And Arizona, the state of Arizona, is on Mountain Standard Time, and it's always on Mountain Standard Time. We don't do any daylight savings time. I'm gonna not slouch there. That's a little better, and I'm backing up a little bit so you just don't get my big ugly head, and that's it. So you can sort of look around in the background. Whenever I watch videos, I always look in the background and see if I can, see anything, nefarious or otherwise. So I don't think you can, and you wouldn't anyway. I've got my CD collection on the wall. You can sort of make that out here, but that goes all the way around the room. But I thought it was appropriate, to have a telescope in the field of view, and it's of course back behind me, but because we're looking at sort of a 2D projection, it looks as big as me. So I look as big as it. So that's kind of fun. All right, cool. So okay, OMCXXX, you are just laying it down tonight, which I greatly appreciate. I'll get to those momentarily. So Astronomy Daily Live, as mentioned, is a daily gathering of friends. Sit around for an hour or so. I don't want to take advantage of anyone's extremely important time and valuable time. So an hour, maybe an hour and a half. It sort of depends. It depends on who's in the circle and what's being discussed. And but I'm going to go for at least an hour. And yeah, if you'd like to be on the live panel, I'm pretty sure I can do that. You just have to throw me an email at cosmiclettuce@gmail.com, and that is in the description as well. And when I go live, I'll send you the link, and you can pop in. And I think that would be really neat. I'm looking forward to doing that for the first time. And yeah, I think I hope that'll happen, because that'll be really fun. So Astronomy Daily Live is just a casual, open-minded, skeptical, fun and educational conversation about astronomy. It's a circle of friends, and you can be a newbie, you can be an amateur, you can be an advanced amateur. I want to get some pros in here to just sit back, chew the fat, talk about things that they're interested in or working on. I'm going to do exactly the same, because I'm one of the pros. Yeah, but I would like a lot of the conversation, to be directed by you. Either questions, which is cool, or just a discussion back and forth. That's very important for science, and it's very important for us, because having different perspectives on things is, as far as I'm concerned, extremely beneficial. And they say that there aren't any dumb questions or stupid questions. Well, I sort of disagree with that to a certain extent. If somebody has a question that is well intended, then absolutely not. There's no such thing as a dumb question. But if your intentions are, to be a pain in the butt, or be like antagonistic or anything like that, I'll say that I am the hammer, and you will go. Easy as that. But topics can be question and answer. We can talk about observing. We can talk about gear. We can talk about telescopes. We can talk about instrumentation or cameras. What else do I have here? Any kind of research, data analysis. A lot of people, don't know what astronomers do, and I was thinking about this today. I probably exaggerated a little bit yesterday in saying that professional astronomers, spend 80 to 90% of their time writing grant proposals. Yeah, it's actually probably more like about half of their time or so, and then about a quarter of their time is spent in meetings, and then the other quarter of their time is doing actual work and or teaching. And usually if you work at a university, you're sort of pulled into teaching a class from time to time, and a lot of academic astronomers who also do research also teach, and some of them are they have multiple classes from Astronomy 101 that almost everybody is required to take, up to grad level classes, and on top of that they do research, and on top of that they have these meetings, and on top of that they're always looking for money, right? Because they got to pay all their students and all their staff to do to work on the projects that they want to work on. So let's talk about what astronomers do. Definitely want to get into reviewing journal papers. Other shows do that, so I want to find maybe a different spin on that. I'm still thinking about that a little bit. Let's talk about the people that are involved in astronomy. The personalities, and who's doing what, and what's the term? I don't remember now. Definitely want to cover things like astro-art. The universe is a beautiful, beautiful place, and how it's represented artistically and creatively actually comes off in a lot of different ways. You think of paintings and drawings and that kind of stuff as art, but software is art. Mathematics is an amazing art form, just absolutely amazing. So yeah, let's get into some astro-art eventually. Definitely want to talk about different astronomical projects and spacecraft and what's going on there, and pretty much anything else, right? That you guys want to talk about. I am not going to slouch. So just consider this, you know, like a daily gathering of friends to sit around for a little while and you know, talk astronomy. Yeah, get away from the TV for a while, get away from the news, and you know, come into this circle and talk live, you know, to people who share, you know, a common interest. And you know, these are people from, you know, potentially all over the world. So I think that's very, very cool. So all right, I'm going to get back to OMCXXX's questions, comments. Um, uh, let's see. Third question: what steps do you take as a scientist to avoid the trap of manipulating your findings to prove a preconceived conclusion that I think is accurate or correct? You know, that happens a lot. That actually just happened uh, to me recently, where you know, I really wanted, you know, to do this project that I thought was going to work out really well in terms of being able to detect very small asteroids um, uh, by looking at uh, the occultations of stars. You know, there are potentially billions of these asteroids, um, and from time to time, um, given a certain location on Earth, and looking at a particular star in the sky, you're going to have an asteroid pass in front of it. And you know, the more asteroids there are, the more occultations you're going to see. And I really wanted that to work. And so I started, you know, crunching all the numbers. It basically works out to a number of probabilities, and probabilities multiply. Um, uh, I worked on that for a couple of months or so, and you know, one day it would be like, yes, this is going to work. The numbers show it. You know, here it is for sure, man. This is it. I've got it. It's going to work. This is going to be really cool. And then, you know, the next day it'd be like, damn, it's just, no, it's just not going to work. It's not going to work. And then the next day it would be, oh yeah, it will definitely work. It'll be completely awesome. And this went on for a couple of months, right? Just up and down and up and down. Every day it was like a roller coaster, really. And I really wanted this project to go, and I could see myself trying to manipulate things to make it turn out the way that I wanted, and but you really just have to let go of those kinds of things. And um, I don't, you know, I call it an intuition, where um, it's it, it's just it's it's a feeling that there's something wrong with uh, with the conclusions you're making. And I've done this enough to I mean, I know when what I'm working on is correct, and I also know what when I'm working on a thing that just doesn't seem right. You know, there's something off about it, and it's just an intuition. I have no other explanation for it at all. Um, And this is a scientist saying that he uses intuition in his work, and I definitely do. I definitely do. So, yep. Um, let's see. Fourth question. No, wait. Regarding my answer to your second question, I suggest that the mass is the mass, regardless of how it's transferred. Yeah, that's exactly what I'm saying. And as I also said, I'm going to have to think about that a little bit, because yeah, I'm thinking of I, I I'm thinking of like spinning asteroids. All asteroids are spinning, right? And that's sort of the closest to moving mass around that you can get, unless you have like some kind of liquid ocean, or um, um, in your example, Titan, same kind of thing. If you got stuff sloshing around that really isn't attached, hard attached. Um, yeah, I'm gonna have to think about that. That's a good one. I like it. I like it. All right. So fourth question, and I've got 3 viewers. Hello, hello. If you're watching this for the first time, or you've watched every single time, make sure to spread the word. Everyone is welcome here. Everyone. I'm just not looking. I mean, I think you're going to get bored if you're not sort of interested in astronomy, but uh, there are lots of reasons why somebody would watch a show like this, and I am open. So yeah. And make sure to let everybody know that I am doing this every single day, same time, 2 hours UTC every single day. Okay, OMC XXX is still landed on here, so he's got a fourth question. How big of an explosion would an average human body create if it was tossed into lava? I don't know. Since temperatures of the lava would well, yeah, this is a very serious question, isn't it? I mean, I would think. See, the thing about science is that you can use it for anything, right? So even a question like that, which I shouldn't be answering at all. I can apply the scientific method, um, and at least come up with some guesses, um, uh, and work through the process. So science works, and the scientific method, if it's applied correctly, is absolutely fantastic. Problem is that a lot of scientists um, today don't apply the scientific method to things. They sort of set things in stone, make them axiomatic, and move on. And sorry, I can't do that. As a scientist, I just can't. I've got to question the questions. Yeah, I've got to question everything. I think that the act of chucking is a and it's a sideways motion with their front legs. So I don't think it matters if they have teeth or not, because the act of chucking wood has to do, I believe, with throwing wood. So I don't think it has anything to do with their teeth at all. Yeah. And OMCXXX, you can make any kind of joke that you want, because I love it. I love it. And what's really funny is when I don't know it's a joke until the end. So that's awesome. Awesome. Okay. Daughter and I want to chip in together to get an entry level scope. Yeah. Okay. Yeah. Yeah. Any particular models that I would recommend? Let's see. I'm not too up on the telescope market. Are you thinking? And sorry, I'm so far behind. But are you looking for a telescope, or do you think like binoculars would be a good start? Probably a telescope, I guess. It's a little more impressive, and larger aperture. Will get you a good deal. This telescope, this is a Celestron Nexstar 8 SE. It's an 8-inch telescope, and I think I dropped like $1,200 for it, if I remember right. It's a good scope, definitely for a beginner. This is probably a little more than what a beginner needs, but getting a C8 is a pretty good. You'll have that a long time. You won't really want to give it away. Celestron is a very, very good brand. Mead is also a very good brand. Probably what I would recommend is a refractor. This telescope is a reflector. It's got a mirror. It's got a mirror at the bottom here. A refractor uses a lens at the front, and it's usually like a big long tube, right? Like that. I don't have a refractor. I don't think I've ever owned a refractor. But refractors are very, very awesome too. Good starter scopes is a refractor. Yeah. So I would say that I'm probably not too qualified to answer that question exactly. Hunt around, go onto the Facebook groups. There's a bunch of astronomy groups. Best recommendation I can give is to find a local astronomy club. And you don't have to be a member, to go to the meetings. Go to one of the meetings and talk to people. Ask them. the amateurs in those organizations are going to be on top of that kind of information, where I'm just not. But I think that's very, very awesome that you are getting her scope, and you all are going to completely be blown away. Now, once you get the scope, I can certainly help you in that arena. Published papers are generally accessible by the public. Am I wrong? Yeah. Let me share my screen. Oh, I'm moving the wrong mouse. Got to go over here. So let me. I'm going to go to this site is definitely my go-to site in terms of professional astronomical papers. This site is called archive.org, and it's arxiv.org. And what these are preprints. Well, they start as preprints, and a preprint is just a sort of, the name implies prior, they papers get accepted, to be published in scientific journals, and then there's a little bit of time between when the paper is accepted and when it's actually published. But as soon as the paper is accepted, the authors can post it. And so what Cornell has done is they've sort of created this site where scientists of all kinds can throw their papers in here and sort of get it published before they're published. Hence the name preprint. And whenever I hear about some kind of astronomical thing that I'm interested in, there's usually like a news article, right, that sort of describes it in layman's terms, which to me is like lame man's terms. It's a lot of the articles, and I can't say all of them, but a lot of the news articles are they're not scientific in any way. They just sort of hit on the high points, and they might show like a picture, but that's about it. But anyway, archive.org is heaven, right? It's just absolutely heaven. So as you can see on the screen here, right, we've got physics, and under that is astrophysics, condensed matter, cosmology, nuclear stuff, physics, quantum physics, and then you get into mathematics and computer science and biology, finance, electronics. So it's just this massive, massive, massive collection of papers that goes back years and years and years. There's a search up here, so you can search, by type, look for words in the title, or look for words in the abstract, look for specific authors. It's awesome, right? And the first one at the top, rightly so, because it's the best one, is astrophysics. And so what I do is I just look at the new ones. There's a recent one too, which is a longer list. But if you look at the new ones here, what it does is it pops up the latest and greatest. And you can sort of tell by these numbers how recent they are. So this is 2018, January, and 5804, 5806, 5808, 5810, okay, on and on and on, right? And it's all these are just these paragraphs are called abstracts, and it's just a really, really condensed description of the paper, right? And so you can go through these and you know, just be completely blown away by all the shit that's going on in the astronomical world. It's absolutely amazing. So I'll just sort of scroll through here and see if there's anything that catches my eye. But each of these papers, and actually once I find one, I'll dive into it and sort of give you a tour. But before I do that, someone is calling at my door. One of the kitties definitely wants in, and I know who it is, and she when she speaks, I must act. So I'll be right back in like 10 seconds. All right, here we are. Rings and gaps in the disk around Elias 24 revealed by ALMA. So, you know, just in that sentence alone, right, there are so many different directions, you know, that you can go. You know, what is Elias 24? ALMA, what's ALMA, right? And actually, you can sort of see in the abstract what ALMA stands for. It's the Atacama Large Millimeter Submillimeter Array, ALMA. So going down here, exotopography, another look at AM Hercules, a star of some sort, globular cluster formation and evolution in the context of cosmological galaxy assembly. It's fun just to read some of these titles aloud because it makes you sound really, really smart. Although you may have absolutely no idea what that means at all, but it sure sounds really, really smart. TRAPPIST-1. Everybody's excited about TRAPPIST-1. If you don't know about that one, go look it up. A lot of excitement about that. Black holes. Everybody's always excited about black holes. Pulsar. Here's the FIP effect and the origins of the solar energetic particles and of the solar wind. So I don't know what the FIP effect is. First ionization potential. Okay. I want to dive into one of these because each one of these papers, as you can see, has a PDF file where you can actually read, you know, the whole paper. I'm just going through here to see if there's anything interesting to me. And you know, these are updated daily, just like this show is. So you come back tomorrow, and there's 20 or 30 more new ones, brand new, not published. So it's very, very cool. You know, if you want to keep this really is the bleeding edge of astronomy right here. This is where it's all at. So I think that is answering your questions about published papers being accessible. Oh yeah. This is a great site. Now there's another site, and it has a distinction of being called vixra.org, which is archive backwards. And vixra is sort of almost exactly the same thing. Okay, almost exactly the same thing, except it's the sort of the out on the edge uh, uh, type things that may not have, they may not be publishable, um, or that kind of stuff. So let's dive into astrophysics here and just sort of see these titles. And again, these are updated daily, right? So you can sort of see what is not necessarily being rejected, but may not be, like publishable type of stuff. And it's like the second one here, okay? Original form of Kepler's third law and its misapplications of propositions 32 through 37 in Newton's Principia. So, maybe not a publishable kind of a thing, but maybe kind of interesting. I don't know. So anyway, yeah, take a look at these two, because these are sort of the alternatives. And if you want to get way out, way out, you go to Progress in Physics. Okay. If you want to get way out to the awesomeness of some really heavy shit, okay, you go to Progress in Physics. Okay. Now these come out quarterly, and for the most part, I think I'm just looking at the most recent volume here, volume 14, which is the first quarter of 2018. And you can look at the titles and see for yourself that it's some pretty wild shit. And this is all very cool, right? And as you can see on the left hand, or on the right hand side here, these go all the way back to 2005. So just some really cool stuff. This is very theoretical physics. This is the edge, but these people are really intense. They are extremely dedicated, and they really seem to know their shit. Whether they're right or wrong, they are extremely passionate. A lot of these authors are independent researchers that are doing their own thing. So yeah, very cool. Let me go back to archive, because I just wanted to pull up. Okay, here's an interesting one: magnetic braids in eruptions of a spiral structure in the solar atmosphere. So obviously, they're looking at the sun, and they're watching eruptions on the sun and seeing these braids. So you click on the PDF here, and that'll open up the PDF file. This may take a little while because I'm uploading this stream, so it takes a little bit longer than normal. And damn, OXCXXX, well, we'll hang around. It's we're at an hour, and I am more than happy to keep going here. I just noticed that Bob Dog is in the house. Glad you could come. Glad you're here. OMC Triple X. You got it. You got it. I will try to remember that, although X is probably one of my favorite letters. and I like saying it. So maybe I'll, sort of go back and forth on that. I'm just sort of catching up on the chat here. Okay, yeah, I will definitely practice that. You're being a great help, and I greatly appreciate all the help, all the help. Um, uh, let's see. Yeah, okay. Not binoculars. You've got those. Looking for. Yeah, yeah. As I said, with the telescopes, I'm definitely not the authority there. As I said, try to find a local club, and most local astronomy clubs have star parties where you can go. They set up a bunch of telescopes, and you can look through them all and see what you like. And you can ask all kinds of questions. Most astronomers that I've met, at least the amateurs, love to talk about their gear, right? So ask them stuff. That's why they're there. Is to show you really cool shit and to answer your questions. Yeah, I heard a good thing. Yeah, I've got a Dobsonian. I actually built it when I was 13, and it's a 10-inch f5.6 with a Newtonian focus on a Dobsonian mount, which is an alt-as mount. So it goes up and down and left and right. And yeah, those you get a lot of bang for your buck, for sure. So look into those. Yep. You are on the right track. Definitely on the right track. And I don't know if you heard me talking about this last night, but don't be fooled by high magnification. You don't want high magnification. The atmosphere, distorts the images of the stars. Let me. I'm going to pop back to me really quick. We can hit this paper here in a minute. But yeah, don't be fooled by high magnification. You don't necessarily want that. The atmosphere distorts what we're seeing, and the more you magnify the image, the more you're going to magnify the distortions. And so after a while, it's just going to look like crap, really real crap, just absolute garbage, right? So don't get fooled into this telescope could magnify 300x. You don't ever want to magnify that much in these kinds of scopes, because you won't see anything. The field of view will get really small, and as I said, you'll magnify all those distortions, so it's just going to look really bad. The magnification is dependent on two things. It's dependent on the focal length of the telescope and the focal length of the eyepiece that you use. So you want to my recommendation is like a 25 millimeter or like a 40 millimeter eyepiece. That is pretty good for any scope, be it a refractor or a reflector. So yeah, you don't want to magnify. It's not going to do you any good, and you'll be blown away. You'll be blown away by the images that you get. Bob Dog heard good things about the Dobsonian telescopes because of the large focal length and affordability, but they're huge and fixed focus. No, not fixed focus. No, you can focus the Dobsonian just like you can any scope. So yeah, that is incorrect. Incorrect. Oh yeah, if you're talking about binoculars, no, I mean you can focus those too. So X is the only letter. Yeah. All right, I'm gonna share this screen again just for completeness sake. Bam. I love all the infinite regressions there. I think that is just so cool. But I'm going to go back to that. And so, yeah, this is just a PDF file that you can download and save and read at your own convenience. And it just, goes through and does most the structure of most scientific papers are like this, right? They sort of lay out what they've observed and what patterns they've seen, and then they will describe what they think is going on, and then if they have any observations, they will describe those. And see, I mean, here, observations of the active event. So they've got an introduction where they sort of lay out the problem that they're trying to solve, and then they get into observations. And in this case, they're using the spacecraft called IRIS, which I've talked about before. IRIS is a satellite that is in a polar orbit around the Earth, but and since it's in a polar orbit around the Earth, it is continuously looking at the sun. There are a couple of times a year where I think it gets blocked by the Earth, but for the most part, it's always looking at the sun, and it is an 8-inch telescope. Okay, it's the size of my scope. So I think that's very, very cool. And I'm looking at the sun mostly in the ultraviolet. But not only is it taking pictures, but it is looking at various spectral features. It's looking at magnesium and calcium and oxygen and a few others. And all that data, tells them about what is going on. So anyway, here are the observations, and then they describe what they're seeing, how they collect the data that they're seeing, and how they analyze the data. And it's kind of okay. Table 1: dynamic evolution of the active events. And so, yeah, this is a detailed description of, there's a time over here and what happens. So, they're really getting into the nitty gritty here. And OMC triple X, fear not, because if this is a good paper, okay, and this is my criteria for a good paper, it's got to have some pictures, okay? So even if you can't read, you can definitely look at the pictures and know exactly what's going on. Totally. All right, I'm going to keep going here. So signatures of magnetic braids. By the way, just as an aside, okay, a magnetic braid is also what's known as a Birkeland current. Look it up. It's a well-known thing in plasma physics, not so well known in astronomy. Braids, especially magnetic braids, have is screaming. It's absolutely screaming electrical stuff. Electrical, not gravitational, not anything else. We are dealing with electrical things. And when you see braiding and ropes, okay, you are looking at an electrical phenomenon. Seeing anything else except electricity going on there. To get a hold of someone who has a paper on something I'm in, get with them, to talk about it. Yeah. I there are current astronomy shows that do that. So I would most definitely like to do that, but I want to think about a different angle. Maybe talking about how they collected the data, or how they did the analysis of the data, rather than the paper itself and sort of the headlines. But what software do they use? Actually, many astronomers write their own code because their work is so specialized that there isn't really anything available out there to do their specific thing. So yeah, I'm thinking about that, but I want to have a some kind of angle, and not just have them basically just reading the abstract. I mean, I can do that, and that would be a waste of everybody's time. So what I'm hoping to see very, very soon, OMC XXX, is what you are waiting for, and that is pictures. There isn't a lot of math in this particular one. I finally see an equation here. A lot of scientific papers, especially the theoretical ones, where they're describing their models and whatnot. Lots and lots and lots of awesome math. You can see all these things in blue. These are references, and I consider a reference sort of a jumping off point, right? So this reference has to do with the statement right before it, and so you can stop right at this point, go to this reference, look it up in archive.org, right, and read that paper. Okay, that paper will have references to older papers, and those papers will have references to older papers. It goes all the way back. This is a launching point into the history of astronomy and to a history of this particular topic. So it's very, very cool. I mean, if you're interested in history, as it is tied into science and stuff, it's all you have to do, right, is grab a random paper and look at all the references. OMC XXX, glad you could come. I'm not going to be too much longer here. It's already 3:14 UTC, so I'm probably going to be packing it up soon too. But I'm glad you came by. Thanks for all the questions. You completely. I mean, I didn't have to cover any of the topics that I was going to cover. So that's awesome. And the really, really cool thing about having a daily show is that I can do it tomorrow. No worries. But I'm going to get through this paper just because I want to see if there's any pictures. So here, you know, at the end of every paper, they have their conclusions, and then they talk about their conclusions. Here's all the references. Here's some pictures. Yeah. So there you go. So even if you're illiterate, okay, you can look at the pictures and maybe get sort of an idea of what's going on. What they are talking about. And oh, there's some more pictures. More pictures. Now they were talking about braids. I want to see some braids. They're over. It sort of looks like what happened? It sort of looks like oh man. These guys have lots of pictures in here. Okay, cool. So they're calling these braids. They're calling them braids. And yeah, and that's sort of how all these papers are. And I don't know about you, but some of these images are, they're all false color and they're annotated and everything else. But if you look at them from sort of an artistic perspective, they're pretty cool looking. I think so. Lots and lots. It's kind of interesting. This paper has sort of mixed the pictures and the references into the same thing. But these are images of the surface of the sun, as you can see here. This is yeah. Well, yeah. I'm not going to get into the details of the paper because I don't want to get that deep into it. But there's plots and pictures, and here's some spectra over here. You can sort of see this dark line, where that dark line is going through. That's an entrance slit to a spectrometer, and then the spectrometer spreads the light out, and so you can sort of see what's going on. So this left and right is wavelength, and up and down is the position. So you can sort of see, you're looking at this bright area here, well, that's this. And you're looking at this bright area here, well, that's that, right? But there's all kinds of interesting things going on in the spectrum, and that is telling them things about motion, velocities, that kind of stuff. This is great. It has lots of good pictures. Lots of good pictures. Here's a little diagram, magnetic field diagram. It looks like a 3D magnetic field. That's kind of cool. I'm not gonna bore you too much more. I just want to give you a good example of what you can expect if you dive into these papers. This is probably one of the more colorful papers I've ever seen. That's the end. Okay, so I'm going to go back to me. Stop sharing. Okay. Boom, Shiva. Okay. Well, there's only one viewer left, and whoever you are, and maybe I do know, I don't know, but I think it's about time to end. This has been really great. OMC, Triple X. Maybe it's Bob Dog. Is it Bob Dog? Are you still here? I can look at the participants. No, it's not. It's not Bob Dog. Okay. All right. Well, you know who you are, and I'm glad you're watching still. OMC Triple X has taken over the show. That was fun. Q&A is always fun, and hopefully I'm not sounding, you know, too authoritative, as if I know anything at all. I'm just sort of showing off, you know, things that I look at pretty much daily, and you know, sharing them with you, you know, the circle of friends. So, all right. On that note, a little bit more hydrogen hydroxide. No, hydrogen dihydrogen oxide. Sorry. Oh no, this is hydrogen hydroxide. Sorry. Yeah, I always confuse those two things. So you know, one is definitely one thing, one, and the other is definitely the other. But I think it is time for me to exit this planet. Um, I will be here again tomorrow. More astronomy talk. This is Astronomy Daily Live. Happens every day at 2 hours UTC. Um, Most of the time, I have a kitty in the lap. Today, she sort of was doing her own thing. I'm glad the lighting is a little better. That makes it better for everybody. I'm pretty happy with that. Not too bad. Not too bad. All right. I'm going to get out of here, and hope you have a great evening and a great day. And I will see you all again tomorrow. Peace.